purpose of this lab is to reinforce your knowledge of velocity of a moving object. Now, what does velocity mean? Velocity, which we represent by v, is the rate of change of position. If an object is here, and after some time it moves over here, and then over here, you notice here that each time the position changes, the change in position is the same. In other words, this is a case where the rate of change of position remains a constant. In such a case, we say that the velocity is uniform. Now, if the velocity is uniform, then the relation between the distance advanced and the uniform velocity is given by x equal to vt, where x is the distance, v is the uniform velocity, and t is the time. Now, you notice that this is similar to the equation y equal to mx. So, if we measure distance x of a moving object at different times t and tabulate them, say like this, we have distance x is in meters, and time t in seconds. You got each x value correspond to a time value. Now, if you draw a graph of x on the y-axis, why? Because x is in the position of y. Look at that, x equal to vt is similar to y equal to mx. So, if you plot a graph of x on the y-axis and time t, always make sure that you have the correct unit. X is in meters and t is in seconds. Now, that graph will be a straight line. If you mark your points, the points would lie almost in a straight line. And remember, when you draw a graph, you will never join the points. You always do a trend line. Not like I'm doing. You need to use a ruler and do the trend line correctly. That is if you are not using the Excel. Now, please watch the video on graphing on Excel if you want to use Excel. Otherwise, you can plot the graph on a piece of paper like this, but remember, mark your axis correctly with all the values and mark your points correctly and show how the slope of the graph is measured. Very important there. Now, how do you take your delta t? How do you take your delta x? Then once you have them, you got to say slope equal to delta x divided by delta t, and now write those values. Delta x is in meter, delta t is in second, so write the value in meter per second. All right, now what does the slope of this graph represent? Now look at this, y equal to mx, where m is the slope, x equal to vt. Now in place of y we have x, in place of x we have t, so what does the slope represent? Slope is in the lab we will allow a car to move through a distance x. Now here I have the table, and measure the time t the time taken for the car to travel the distance x. Then calculate the speed as distance divided by the time. Now we will repeat the procedure for 9 different x values, and each time we measure the time. That means you will have 9 different speed values. Then calculate the average speed and record it here. Now make sure that you use the correct unit for the average speed. You will lose 1 point for not using the correct unit. Now that we have 9 sets of distance and time values, you need to draw a graph with distance on the y-axis and the time on the x-axis. Now measure the slope of the graph. If you haven't watched the graphing video, you should watch that before you do this activity. Now measure the slope of the graph and show on the graph how the slope is measured, like I have demonstrated in the graphing video. Choose your delta x and record it here with units. Choose your delta t and record it here with units. And calculate the slope as delta x over delta t. And write the slope with the correct units. Now remember, the slope has a physical meaning. If you do not use the correct units, that physical meaning is lost. Alright, let's now go and do the lab activity. Now here I am going to run the car through a certain distance x. You can measure that distance x here, and the time can be read on the clock. Alright, let's do the first trial. I'm going to start the car and stop it. This is the first trial. Measure the x and t values. I'm going to reset it. Let's go for the second trial. Stop the x and t values for the second trial. Let's reset it. Start the third trial. There you go. You got the x and t values for the third trial. Let's reset it. Start the fourth trial. There you go. Measure the x and t values for the fourth trial. Let's reset it and go for the fifth trial. Alright, measure your values now. Reset it. Let's go for the sixth trial. Alright, take your measurements now. Reset it. Let's go for the seventh trial. Stop it. Take your measurements. Reset it. Let's go for the eighth trial. Take your measurements now. Reset it. The last trial. Alright, you have 9 sets of measurements. Find the speed each time, measure the average speed, then, I repeat, do a graph of x on the vertical axis, time t on the horizontal axis, and show how the slope is measured